Hey, what's up? It's Sunny here, bringing you guys another video. We're going to be doing something a little bit different today. I'm not going to be doing a full-length boot to root penetration test, and I'm actually not going to be continuing my boot to root series at all because YouTube came out with a policy just this year saying that channels are not allowed to upload any content which can teach viewers exploitation techniques that could potentially be used to gain access to any sensitive or private user data. So I'm going to be staying away from any exploitation techniques in my videos moving forward. But that's okay because today we're going to be looking at reconnaissance and enumeration. Specifically, we're going to be building a tool that will actually automate these steps for us. Now, if you remember from my last video, we have the Chioptrix virtual machine here that is just waiting to be exploited. We actually went ahead and got root access in the last video, so if you want to check out how to do that, you can always go ahead and give that a watch, but that's not the point of this video. We're going to be automating the reconnaissance and enumeration that we did manually in the last video, just to go ahead and make our lives easier. So I'll actually demo for you the Python script that we're going to be writing in just a sec. Before we go ahead and do that, however, let's go ahead and make sure we're connected to the internet. And it looks like we are not, because in ifconfig, looks like the only networking interface is our local loopback. 127.0.0.1 is our localhost IP address, and I can verify this for you by trying to open any web page. Anything I try to go to, it's not going to let me connect. A way you can also test this from the terminal itself is to just try to ping any domain, and it's not going to work out. Now, what we actually have to do here is bring up our networking interface. In my case, it's ETH0. So the virtual machine thinks that I'm on a wired connection, which is what the ETH stands for Ethernet. Even though I'm running this on a MacBook, which is using Wi-Fi, because my VM is using network address translation, or NAT, which will make the VM think that my host machine's connection is a wired connection. So that's why I'm using ETH0, but if you guys are running Kali Linux on like a Raspberry Pi or something, and you guys are actually using a real wireless connection, then your networking interface might be called like WLAN 0 or 1 or something like that. You might be using an external Wi-Fi adapter that supports packet injection or something like that. So, excuse me, just something to be wary of. So, moving forward, I'm going to be using ETH0, but you guys should substitute that in with whatever appropriate Wi-Fi interface works for you. So, I have to use ifconfig ETH0 up, and then after running that command, and I'm not going to run it just a sec, I'll show you guys why. After running this command, I will run dhclient and then the name of the networking interface. Now, the reason I didn't run the initial command is because I'm going to show you guys a cool little bash trick you can do, which is I can put the first, basically what this is doing right here is I have the first command, ifconfig, let me move this out of the way, ifconfig eth0 up, $ampersand, dhclient eth0. What this is going to tell the terminal to do is run this command. If this command is successfully run, then go ahead and run the second command. If you guys have any programming knowledge, this $ampersand is actually a Boolean operator which will check to make sure that this actually evaluates to a truthy value. Bash commands actually return truthy return codes to the terminal, and if this command failed to execute successfully, then it would return a falsy value, and it would not evaluate the second part of the expression. But if you don't want to think about it that deeply, then just know that you can put in one command, add in a $ampersand, and a second command, and all that'll tell the terminal to do is only run the second command if and only if the first command is successfully run. So run the first command. If it's all okay, then go ahead and run the second command. So that's what we're going to do here. And now we can go ahead and try to ping www.google.com, and it looks like we're getting responses back from the server with 0% packet loss. So another reason I wanted to show you guys this is because you can actually do something really handy called bash aliasing. Now, that long command, this one right here, might be a bit inconvenient if you forget it after a while, or if you're constantly having to reset your networking interfaces. It's kind of a pain to type out over and over again. So what you can do is alias this into a shorter command. And one that I personally use is called Wi-Fi up. So the syntax for this is alias, the name of the new short command equals, and in quotation marks, the longer command that you wish to alias. So alias Wi-Fi up equals, in quotation marks, ifconfig eth0 up, double ampersand, dhclient eth0. Now, let me go ahead and manually bring down my networking interface just to show you guys this in action. So let's try to ping www.google.com. Not going to work out. Run Wi-Fi up. Try it again. Bam. There you go. 0% packet loss. See how easy that was? I didn't have to type out that really long command or mess up any of the syntax or anything. All I have to remember is that if I want my Wi-Fi to be up, I just run Wi-Fi up. Now, if I want to test my ping, then something that a lot of people do is they only send one packet. This -c flag is to indicate the count. So ping -c1 to the domain that you wish to ping. So you can see it automatically terminated the ping after sending one packet. And I actually alias this as well as test ping. So let me show you the entire thing in action. So starting from the very beginning, my Wi-Fi is down. In order to double check that, I run test ping. Not working out, Wi-Fi up. Now to make sure that it's up, test ping, and there you go. 0% packet loss. All I had to do was quickly type out these 3 really short commands, and I now know that my Wi-Fi is up and I'm ready to go. Alright, so let's actually go ahead and take a look at the script that we're going to be writing today. I have that aliased as well as test here. So you can see at the very beginning, it finds out our IP address and then runs a netdiscover. For the purposes of this video, I'm going to assume that you either have watched my Keyoptrix boot to root or you are familiar with basic pen testing and at least some of the really common tools that are used in pen testing, like netdiscover and Nmap, which are going to be the 2 tools that we're going to be taking advantage of in our automation script. So it took our IP address and then ran a netdiscover on our local subnet, which is our IP address, but replacing the last octet with the values 0 through 255. And it has returned for us the 4 IP addresses that were found by the netdiscover's ARP scan. So you can see 192.168.29.1, 2, 148, and 254. These values can range from 0 to 255, so the ones at the boundaries don't really concern me. We believe that 148 is our Keyoptrix VM, so it prompts us to enter an option 1 through 4, which are enumerated here, or 0 to exit the script, which I'm not going to do that, just to show you guys the script actually working. So I put in 3, and it's actually going to go ahead and run a staged Nmap scan. So if you remember from the last video, Nmap scan staging just means that we're going to do a quick TCP scan on all of the open ports, 1 through 65,535, and once we do that, it's going to output the ports that are open, 22 for SSH, 80 for HTTP. Now we remember from the last video, this was our Apache web server, 139 was our Samba server, I believe. So it's going to display the results from the fast TCP scan, and once it knows which ports are actually open, it's going to target these few ports for an intent scan. So you can see how long it's taking to run the intent scan on these 6 open ports. Now you can imagine how long it would take to run the intent scan on 65,000 ports, which is just absolutely unreasonable. So that is the whole purpose of scan staging. You do an initial quick scan on all of the ports so you can get an idea of which ones are actually worth running the intent scan on. And then you actually specifically target those. And I touched on this in my last video. This is just a way to be much more efficient with your time, just so you're not wasting your time intent scanning ports, the majority of which will be closed. So, yeah, we'll just let that run, and the end goal of the script is to output the results of the intent scan into an output.txt file, which will just be handy for us to refer back to during the pen test later on. It will kind of keep your terminal nice and clean, get rid of all of that clutter, because the verbose output of an intent scan can be really long to sort through, really easy to get lost in, which is why I think it's more convenient to just output all of the results into a text file and let them sit there for whenever you need to access them. So there you go, Nmap intent scan results logged in output.txt. And you can see it's right here, so let's go ahead and take a look at that. And if you remember from the last video, this is just the verbose output of the intent scan. It shows us a lot more detailed information about all the services running, so you can see we have some information about SSH running on port 22. And remember, this is the default port that SSH runs on. Apache web server version 1.3.2 running on port 80. We have our Samba server running on port 139, which is what we actually took advantage of in the last video and exploited to get root access. Operating system information, then Nmap intent scan's best guess as to what version of Linux is being run. So it's estimating 2.4.9 to 2.4.18, something like that. So yeah, all of this information is just waiting for us in output.txt whenever we need to refer back to it. So that's basically what the script does. Let's take a look at it from the beginning again. It will fetch our IP address based on our networking interface, which in my case is ETH0, run a netdiscover on our local subnet, allow us to choose one of the IP addresses that are returned from the netdiscover ARP scan once we pick an IP address, in which, in our case, we picked 3, 192.168.29.148. You can see that we began our Nmap scan staging by scanning all TCP ports on this machine quickly, and once we found out which ones are actually open, we ran the intent scan on those open ports. So that's basically exactly what we're going to be building out ourselves today. Now, let me go ahead and in a new window, I'm going to use a simple editor called gedit, and let's create a new file called scanner.py. Now, if I hit enter right here, it will open up gedit and the terminal will just be hanging here. I won't be able to type any more commands in, so a handy little trick is you can append a single ampersand, and that will actually spawn gedit as a process, which you'll be able to see the process ID here, and it'll leave the terminal open for me to continue running commands in. So yeah, there you go. Now I can do whatever I want in here, and this terminal instance is still open for me to do whatever I need to here. It's just a neat little trick. So we have gedit open. Let's go ahead and get started with our script, shall we? We're going to include a header so that our computer knows how to actually interpret the file. We're going to do # exclamation mark usr /bin /env and Python. So we're going to be writing a Python script in here. And our script is actually going to take advantage of some bash commands. So in order to actually execute bash commands within our script, we're going to have to import a module called subprocess. And I'll show you guys what the subprocess does in just a sec, because we're going to need that to fetch our IP address. And we're going to be fetching our IP address the same way we've actually been checking our IP address by running ifconfig. Now, as you can see, we have 2 IP addresses here. inet means that's our IPv4 address, which is what we're going to be using. Now we have an inet address for ETH0 and an inet address for LO. This is just our localhost address, and we don't want that. So in order to just get the IP address that's not our localhost that we're actually going to use, we can just run ifconfig eth0. Passing in the networking interface itself will only give us the output for that specific network interface. As you can see here, we don't get the loopback address. There, that's a lot cleaner. I'll go ahead and actually execute this command within the Python script for you guys. So let's say result equals subprocess.check_output. This function is going to take an array of 3 elements, the first 2 of which will always be the same, bash and -c. Now the third element is going to be the command that you want to run. So in our case, let's type in ifconfig eth0. This is going to store the result into what we so aptly named result. So after this, let's just print out result to the screen. Save that, python scanner.py, and it's doing the exact same thing as just running ifconfig eth0, but it's storing this output into result and not actually I just want to make it clear that this output is not coming from it's not actually being displayed by the execution of this bash command here. If I go ahead and delete this print statement and rerun the Python script, nothing is outputted, even though this command was executed. Now go back, include the print, and actually just to make this really clear for you guys, this is from the Python print statement. Then we'll put this on a new line, save, and you can see that very clearly this is coming from the Python print statement itself, not from the execution of the command. And that's going to be really handy because that way we can get to choose whatever we want displayed to the output, which is what actually allows us to give us such a clean interface for our tool here. So now, okay, so let's see. We have this output saved into result, but how are we actually going to extract our IP address from this? This is what we want. So we're going to be using a something called grep. If you're not familiar with what grep is, let me just put some output on here, or okay, let me keep this up here. So what grep will do is it will basically search for a substring within the output of some command. So in our case, we want the inet address. So what we can do is we can search for this string right here, inet space. If we just search for inet, it will actually continue to give us the inet6 address, because technically inet is a substring here, but inet space is only found within this line. So passing inet space as an argument to grep will return us the entire line that matches that substring search. I'll show you that to you guys right here. ifconfig eth0. You use the pipe, which on a Mac keyboard is shift and backslash, which is the key right above enter. So you type in the command, space, pipe that into grep, and pass in the substring that you want to search for, in quotation marks. And as you can see, this is the line that was returned. That's why we have all of these extra spaces here. So if I add in our grep condition, then we should have the IP address line now saved into result. So yeah, this is the first line from the Python print statement, and then on the next line we're printing out the result string, which is the line from the ifconfig output. Now, how are we actually going to get our IP address here? what we can do is strip. We can use a string.strip Python method. Let's call this something more descriptive, IP string, and IP is going to be equal to IP string dot strip. And I'm just going to be printing out the IP variable because that's all we're concerned with. So let's see what we're at now. So yeah, now we got rid of all of the leading and trailing white space. That's what the strip command function does. And what we're going to do here is we're going to split this entire string based on the empty space. And what that's going to do is create an array where each element is a substring that is separated by the empty space. So the first element in that array will be inet, the second element will be our IP address, the third should be netmask, and so on and so forth. So I'll show you guys that here. .strip.split and pass in our single empty space as an argument, and now I'll print that out, and as you can see, now IP is equal to this entire collection here, where each element is what was separated by spaces earlier in the string. So now all we want is the element at index 1, the second element. And this, let's just go ahead and cleanly format this. Your IP address is, oops, there we go. Your IP address is this. And you can see how cleanly we were able to get this just by combining the handy grep output from the bash command and then manipulating the string using Python. So Python and bash together can become a very powerful tool, especially when you want to output very handy information to the terminal very quickly and efficiently. So let's see, we have our IP address. Now what we want to do is actually use the IP address and run a netdiscover on the on our local subnet. Now for the purposes of this video, we're going to assume that your subnet is a 24-bit subnet mask. And if you're not familiar with what that is, then like I mentioned in my earlier video, you should probably brush up on some networking fundamentals. But basically a subnet is the range of IP addresses that machines connecting to your local network can be assigned. So if you consider this as a 32-bit number, this would be the first 8 bits, this would be the first 16 bits, and this would be, even though this is 2 digits right here, this is still a 8-bit number. So these would be the first 24 bits, and this final octet would be the last 8 bits. So the way that netdiscover actually scans IP addresses in your subnet is you pass in a range in a notation that is known as CIDR notation. That's CIDR. Stands for classless interdomain routing. So we're going to pass in our subnet in this notation, which is CIDR notation. The .0/24 means that we're going to keep the first 24 bits of our IP address the same and only vary the final 8 bits from 0 to 255. So if I run this here, we should see the same IP addresses that were displayed by our tool, but this is a much cleaner output. And as you can see, .12148.254, 12148.254. So that's exactly what we're going to be doing. Now, this is going to be, let me see here. We're going to be running another netdiscover bash command, meaning we're going to be using the subprocess.check output. Now, I think this syntax is a little unwieldy. So we're going to extract this out into its own function that we're going to call bash, which will take a command, which will just be the command that we want to execute. So if you're not familiar with function declarations in Python, you type def, which is the keyword that shows that you're defining a function. the name of your function, and in parentheses, whatever parameters or arguments you want to provide it. And what we're going to do here is we're going to return from the function the result of calling this subprocess.check_output. And this is also useful because we know that the first two arguments in this array will, the first two elements, in this array will always be bash and -c, and the third can just be whatever command we pass in to the function. So we can rewrite this to be a lot cleaner. IP string equals bash, and then just the actual command that we want to write into our bash shell. So IP string equals bash ifconfig eth0 piped into grep using the substring inet space. If we save this and run it, we should have the exact same, python scaram.py, exact same output. So this is all working just fine, and this will be handy for us because we're going to have to make use of this bash function in just a little bit when we actually run our netdiscover. Now, if you remember from this netdiscover command, we have to take our IP address and we need to extract the first 3 octets from it and actually hard code in a 0/24 at the very end. Now, it would be very simple for me to just take a substring of this and leave out the last 3 characters, but if you notice closely, the third octet here, this is an 8-bit number, but it's only being represented by 2 digits here. Meaning that some of you may have IP addresses that just end in, maybe your IP addresses end in 29, or end in a single digit. Maybe it just ends in like 7 or something, which is why, for the purpose of being compatible on any machine that runs the script, I'm not going to simply take a substring. We're going to be delving into a bit of a more involved process. So let's call the first 3 octets that we want to provide into our netdiscover command. Let's just call them octets. So octets equals, now what we're going to want to do here is split up our IP based on the period, because we're only going to want the first 3. We're going to leave out the last element. If you remember what split does, it takes in an argument. Earlier we used the empty space, but now we're going to use a period, meaning it will split up the IP address into an array of elements, and each element will be whatever's separated by the periods. So it should be an array of 4 elements. First element should be 192, then 168.29.130. It's really quite intuitive. I'll just go ahead and show you an example right here, and I'll print the octets array for you just so it's very clear to see. So as you can see here, the element is, the collection is clearly printed here, 4 elements, and what we're going to want to do is combine the first 3 elements. So we're just going to leave out the last element, and we're going to join them together with periods. So it looks like we're taking the IP address, getting rid of the periods, taking the first 3 elements of the array, and then combining them again with periods. So it kind of looks like we're doing a lot of hard work here, but it will be worth it in the end, just because you never know if your IP address will have 3 digits or 2 digits or 1 digit. So just so you don't have to worry about that, this script will be guaranteed to work regardless of how many digits are in the final octet of your IP address. So the way we can rejoin the first 3 elements is, let's just work with all of the elements up to the last one. That's what this is going to do for us in the square brackets. Colon and then -1 means all of the elements up to the element at index -1, which is basically the last element. So this is exclusive. It's not going to include this element. It's only going to operate on the first 3. And we're just going to join them with a period. To surround all of this with parentheses. Now, let's test this out. Dot join. IP.split. Invalid syntax. Let me see here. Split. -1. Oh, I just missed my period there. Yeah, so this is actually a function that is part of any string that you can pass in. So you can consider this as string.join. I just missed the period there. So now let's try this again. And as you can see, from the IP address, we have successfully extracted the first 3 octets. Now, we can just really cleanly add in .0/24, which is the ending of our subnet insider notation. And now, just as we clearly formatted the IP address here, your local subnet insider notation, just for clarity, is subnet. .192.168.29.0/24. So we're good to go. Now all we have to do is run our bash command. So our netdiscover is going to return in the output all of the different IPs. So let's call them IPs equals bash. And remember, it's going to be taking advantage of this, but saving us the trouble of having to rewrite this over and over again. And we're going to pass in our command, which will be netdiscover-r, and that's going to take in the subnet range. But I can't exactly just type in subnet here. What we're going to do is something called string formatting in Python. I'm going to put in a %s, and after that, %s, at the end of the string, let's see, is this right? I believe it is. Here, before I get into that, let me just So I'm just going to comment these out with a £sign for now, and just show you guys the string formatting really quickly, make sure that I'm doing this right. So I believe the syntax is within a literal string, you can use the %s, and then after the string, you can add another %, and then the string that you actually want to replace. So let's try that out. String formatted subnet, yep, looks like that worked. So if you still can't see what's going on here, string formatted subnet, :space, and as you can see, %s isn't what's outputted to the terminal here. What's actually outputted is whatever variable we passed in after the % that follows the string literal. So this is called string formatting. So very, very handy for dynamically executing different bash commands like this, because it wouldn't make sense to try to hard code this in. You want to actually pass in whatever variable we've spent so much time extracting so far. So netdiscover-r, %s, and sorry, this is going to be subnet, not octets. And I'm actually going to pass in a -p flag, which will just, if you remember from netdiscover, if we pass in 192.168.29.0/24, if I pass this in, it's going to keep hanging like this. That's not what we want. What we want is to just like our ifconfig did. As you can see, the command executes and just is waiting for the next command. In order to get netdiscover to do that, you can just pass in a -p flag. As you can see, it didn't hijack the entire terminal window. It's going to go ahead, run the entire scan. Once it's finished, it will go ahead and continue to listen for the next command. So that's what the -p flag does. So we're going to go ahead and pass that in, netdiscover -p -r %s, format in our subnet string, and the result of that will be stored into IPs. Now, it's safe to say that this is pretty much what this entire output is what is stored in the IPs variable right now. We haven't done any sort of grepping at all in order to just narrow this down into the clean syntax that you see here. So this is going to take some work on our end. What we can do right now is to just go ahead and print this out, just so you guys can go ahead and double check to make sure that our command executed properly, it's properly being stored into IPs, and yeah, as you can see, the netdiscover didn't hijack our terminal instance, and the script finished executing, and this is all what is stored in IPs. So what we're going to have to do here is, let me think about this. I think what we can do is iterate over these, maybe? Okay, yeah, we're going to want to iterate over these IP addresses, and in order to do that, subprocess.checkOutput, the result of that actually comes with a really handy function called split lines. And here, I'll go ahead and rerun this for you now with the split lines, and you'll see that each line actually turns into an element of an array. Now, I know this is not formatted very nicely, but you can see the closing and opening square bracket of the collection right here. So every single line here is now an element of this array. So what we can do is we can go ahead and iterate over it. So let's say for I in, now range is just going to give us a handy sequence of numbers from 0 to the length of this IP's collection. So this is just a simple for loop that we're writing here, and within the loop, let's say that IP is equal to IPs, the element of the IP's array at index I. So this will be a new IP for each iteration of the loop, I mean. And let's go ahead and just print out the IP. Let's see what this gets us. Okay, right, so we're just iterating over each element in the array one by one and printing all of them, so it's not really anything different here. Okay, so what we're going to want to do is start cleaning up our output, and we're only going to be concerned with the IP addresses returned here. So if you remember from this command, we're going to, again, make use of grep. As you can see, something that is only found within the IP address lines looks like, what, 160? I think 1 is safe because, like VMware, that is really only specific to my virtual machine hosting software. But any netdiscover will return an IP address if it was found one time through the ARP scan. Now I'll delve into ARP scanning and ARP protocol and all that in a little bit, and kind of why I prefer using this method of netdiscover over another really popular technique called ping sweeping. If you remember, we actually just used ping at the very beginning of this video to ping Google's public domain. But the thing about ping is some machines can have different firewalls set up that can actually choose not to respond to the protocol that ping uses, which is ICMP. I believe that stands for Internet Control Message Protocol. So a ping request sends out an ICMP packet to a machine at a specific IP address, and different firewalls can be configured in such a way, which is actually quite smart, in that the machine will choose to ignore any incoming ping echo requests. And the thought process behind that is that if a black hat hacker is trying to do some reconnaissance on a network, they might do something called ping sweeping, where they just send out these pings to all of the machines on a certain IP range. And if your firewall isn't configured like that, then they'll find you, or they'll get a response back, and then they'll know that you are a potential vulnerable target. So configuring your firewall to ignore ping requests kind of like hides your machine from people who do ping sweeping. Now, netdiscover uses something called ARP scanning, which stands for Address Resolution Protocol, and the ARP protocol is actually quite clearly displayed here. It's the protocol that is used to tie a specific MAC address to an IP address. A MAC address is a unique hardware identifier that is unique to every single networking device. And there are actually quite a few things you can do with your MAC address. You can do something called MAC spoofing, where you manually change your MAC address to maybe mimic a different MAC address. Say you want to have whitelisted access onto a network or something, or maybe your MAC address was blacklisted onto a network and you want to spoof your MAC address to something else. So yeah, that's something you guys can look into on your own. But anyway, that's kind of why I prefer ARP scanning over ping sweeping, which is why I chose to use netdiscover in this tool. Okay, so where were we? Right, we have to clean up our netdiscover terminal output. So what we're going to do here is we should pipe this into a grep, and we're going to pass in 1. So that should at least just return these 4 lines. Let's just double check that. Your IP address should say our subnet, maybe? Oh no, I don't have any prints for the subnet. Okay. I'm just gonna add in one more line of spacing between these. But yeah, as you can see, we're getting there. We got our 4 lines that are just the IP address. So that's good. Now, what we want to do is only get the IP addresses. So what we can do here is actually we can, just like how we piped this output into grep, we can pipe grep's output into another really handy tool called cut, which takes in an argument called a delimiter. And what cut will do is we're going to cut based on an empty space. We're going to cut based on an empty space and use -F2 to select the second cutted field. Now, I'll go ahead and show you guys what cut does. It's actually very simple to split, the Python split method. What it's going to do is it's going to take each line and separate it based on the delimiter of an empty space, meaning that this will become its own field, perhaps this will become its own field, this will become its own field, this will become its own field. It's kind of like how split separates a string up based on its own delimiter argument and creates it into an array. Kind of like that, we're using this -F2 to say we want the second field of the cut output, which is kind of like saying we want the second element of the split array. That's kind of how you want to imagine this. So here, this will make it really clear. I'm going to keep this above output, and you'll see how the cutting, as we move through different fields, will change the output. So at the beginning, I'm suspecting we'll probably just get empty spaces. Yeah. Okay. Let's cut out the second field. Okay, so this is what we want, just the IP addresses. Now, just to show you the proof of concept, let's cut out the third field, and I'm expecting that we should just get the MAC addresses. So here's something you can do if you want to, oh no, we're not. So looks like we're just getting returned empty spaces again. Oops, sorry about that. Okay, I see what's happening here. So yeah, this might not work out too well because, as you can see, the final octets of each IP address are actually varying in length. These are 3 digits, these are 1 digit. So like if I try to cut based on the 4th field, then yep, just as I thought. You can see that it gives us the MAC address for the final 2 found IP addresses, but we're still getting empty spaces for the first 2. But anyway, it's okay. All we're concerned about is the IP addresses. So we're going to go ahead and get the second field, clear this out, just make sure everything's running okay. Gives us our IP address. Now it's running netdiscover. And just for some clarity, let's say that after we retrieve our IP address, right before we run the command, let's print out running netdiscover on local subnet, and keep this here. Okay. So yeah, just so it's a bit clearer to the end user that we found our IP address. Now we're running netdiscover and displays the IP addresses that were found. All right, now what we have to do is we have to actually prompt the user for some input, enumerate the found IP addresses, and then once the user selects an IP address to scan, we will start initiating our Nmap scan staging. So let's get into this. So how should we do this? Okay, so going back to our pre-made script for inspiration, so it looks like where we are printing out the IP address, we should actually do a little more fancy formatting here. So we're going to print out 2 variables here. Just like how in our netdiscover we formatted 1 string, which was our subnet, into our bash command. Here we're actually going to be doing some formatting on 2 strings. I think that should do the trick. The first is going to be what we're iterating over, because as you can see here, it's kind of like this is the first iteration of the IP address array. This is the second, this is the third, this is the fourth, and the I iterator variable is pretty much what's keeping track of that for us. So yeah, let's just model that exactly like how it is in here. So the iterator space dash space IP address. Okay, and we're going to go ahead and format this. Now we're going to be passing in 2 variables here, and what we can do is we can pass them in through a tuple, which is just like a list. So we're going to pass in I and the IP. Now I believe I will actually begin at 0, so we're going to pass in I plus 1. Let's see if that works. Running netdiscover. Okay, so it's starting to look more and more like this. Actually, it looks exactly like that. That's what we want. Now what we need to do is prompt the user for some input. So let's print out, actually, we can prompt for the input right here. So we're going to use a function called input and put in our prompt string, enter in option 1 through, let's see, we're gonna have to dynamically assign the size or the length of the IP's array. So this is going to have to be a formatted string, or 0 to exit the script. And new line. Okay. And we are just going to format that with the length of the IPs. So this will prompt our user, and we can store their response into a variable called choice. Let's just make sure that this is working right. Enter an option 1 through 4, or 0 to exit the script. Okay, great. Now what we're going to want to do is, okay, let's make sure that we actually are able to get their choice IP address that they want. So let's print your choice is, and I believe it should be the element at choice. Now since here we added one, in order to get the index we're going to have to subtract 1. So running netdiscover on local subnet. Turn option 1 through 4. So let's just try this out with 2. If we enter 2, your choice is 192.168.29.2. So looks like we were able to get their choice. Okay, so now that we are able to get their choice IP address, we have to start thinking about how we're going to initiate the Nmap scan staging. So looks like we're going to want to make use of another function here. Yeah, alright. We're going to make use of another function called Nmap. Let's call it Nmap scan. Scan seems like a more active word. Nmap scan is going to take in an IP address, and let's see, we're going to print, just so that we're making it very clear to the end user. So scanning TCP ports, scanning TCP ports on IP. And as you can see, the way I've just been like adding singular strings at the end of a print, you can also, if you're feeling fancy, go ahead and use the string formatting that we have been talking about. So instead of just printing out the choice here, let's go ahead and actually pass in our IP address. So that was IPs at choice -1, right? Whoops. Okay, so the end of this code flow should put us into the Nmap scan function. Let us know that we're going to initiate scanning TCP ports on the IP, and then we'll just feel good knowing that we are properly in the Nmap scan function, and we can go ahead and build out the rest of this function here. And I'll just go ahead and try a different choice here. Scanning ports on 148, which is the one I chose. Okay, so we are at the final stage. We just have to actually carry out the staged scan now. So let's see. We're going to store this in a result variable. Result equals bash. Now let's think about how we want to do this. We're going to pass in our nmap bash command, which will be nmap -t4, which is just our timing template, -p 1 through 65,535. This is going to tell Nmap to scan all ports on the machine from 1 through 65,535. And we are just going to pass in, okay, actually, let's go ahead and do this. In order to help us figure out exactly what information we want to pass into our bash command here, let's actually run an Nmap in our terminal really quickly. Nmap-t4-p1-65535 192.168.29.148, and I'm going to add the -v. So I don't think I need the verbose output. It should automatically display to the terminal. Okay, so we can imagine that this entire output is what would be stored in the result variable. So we got to go ahead and start thinking about how we want to start grepping out just the lines that we're concerned with. Looks like open? Would open work? Yeah, it looks like all of the lines which output information regarding open ports all have the unique phrase open in them. So looks like here in Nmap we can pipe this into a grep open Is that really it? Yeah, looks like it. Okay, so now let's go ahead and format in our IP address, which will take place of the %s. And I'll go ahead and print res, just to make sure that we have successfully extracted only these lines. All right, let's choose 3, scanning TCP ports on the machine. Okay, looks like that did the trick. All right, now that we have our outputs grepped to only the open ports, what we're also going to want to do is iterate over these, because we're going to extract just the port numbers and set them up into, going to get those open ports ready for an intense scan. So what we want to do is also split lines here, and let's see, let's track the ports that we want to intensely scan in a collection, in a list called ports, and let's go ahead and start iterating over our ports in the response. So for port in res, we're going to, let's continue to print it out, because we want that nice clean output here. We're going to print it out, but we're also going to insert into our list just this first element right here. So what we can do is we're going to do ports.append, which will append to this ports list, or just insert a new element at the end. What is this going to be? Looks like we can split this up based on the slash. All of the port numbers end with a slash. So I think that should be good. Should be good. Port.split, pass in a slash, and we just want the very first element from that array. Should just be that. And let's make sure we're good to go here by just printing out the collection at the end. It should just be an array of these open ports. Sorry if you guys are getting tired of watching me test the script over and over and over again, but I find that just incremental testing in this way, at least that's the process that works for me. Okay, looks like we were able to print out the collection of open ports successfully. Okay, now looks like we have the open ports collected in this array from our fast scan. All we have to do is get them ready for our intense scan. So just like how we specified the ports here through a range of 1-, 65, 535. You can also specify ports like this, like 1, 2, 3, 4, 5, 8, 9, 100, 101, 102. So if you see here, what we're doing is we're just joining all of the different ports with comma between them. So let's get that back to what it was. So if you remember what we did in our IP address, when we were trying to separate out the first 3 octets, we called the Python .join method, which basically gave us a new string with each element in our split IP array. They were all joined together, quite literally, using this. And we're basically going to use the .join method again, but instead of a period, we can use a comma. So let's call this the port list string. So that should equal comma dot join ports. I'm not going to go ahead and print out the port list and try to do all the testing. I think we should be good to go. Let's just like how we printed that we were doing the TCP port scan, let's print out that we're running the intents scan on open ports, just to give some information to our end user. That nice on its own line, and I think we should be good to go on setting up our final bash command. So this should be nmap -t4, our timing template. I'm going to go for -a to encompass all of the useful scans, which will include version detection and OS detection. -sv, which I believe is actually specific to Surface version detection. And okay, so this is the important part, -p, and right after that we're going to format our port list variable string. Yeah, now what we actually want to do is store the output into a file, and we can specify that here by passing -on and then the name of the file, output.txt. Let's see. Oh, okay, we need to also, at the very end, yeah, we have to pass in our IP address. Don't want to forget that. Okay, so another dash or %s. Gonna have to put this in a tuple. Oh, whoops. Port list IP. Yeah, gedit isn't really the best code editor. It's just what was installed on this already. I really gotta get like PyCharm or something on here, though. Okay, so let's see. Nmap -t4 -a -sv. The port list string. Output that into output.txt, and finally our target machine. Looks like that should be the final command that we need. Let's print out nmap intents scan results, logged in, output.txt. Just feeling lazy, did a lot of typing, so I'm just gonna copy and paste that in here. And let's see, I think this should be everything we need. Let's give this a final test run. Let's remove everything that we're not using and make sure that whatever shows up in here is the outcome of our new fresh script that we have just coded together from scratch. So let's run python scanner.py, IP address 192.168.29.130, running netdiscover, prompting us to select an IP address from our netdiscover ARP scan to nmap stage scan. Gonna choose 3, which we believe is our Chioptrix VM right here. Scanning TCP ports. Displays the ports. I guess I didn't get rid of the print statement right here. File, new tab, ls, okay. Oh, is it done? Let's see what's in here. Oh no, I guess it's just getting ready to write to that file. So let's just wait for this to finish, and that will be the moment of truth. If you remember the beginning of the video, an intense scan, even on simply 6 ports, can take quite a while. While I'm waiting for that, I'm just gonna go ahead and clean this up, because we don't need this print statement at all. I'm also going to separate this prompt out a little bit. Enter an option, just put that on a new line. And we will just wait for this to finish up here. Nothing yet. I'm really tempted to just kill this and rerun the script with the cleaner formatting, but I'm not going to make you guys sit through all of this again. Probably just going to fast forward this part of the video, honestly. Okay, here we go. So, Nmap intense scan results logged into output.txt. And let's cat that out. And lo and behold, we have our verbose output from the intense Nmap scan. Now, it actually finished in a somewhat reasonable time. It was probably like a few minutes or something. I don't know if it was even a few minutes. It just felt like forever. But since it actually finished, that's indication enough that it actually only scanned the 6 ports that we joined together by commas here. Because if we were scanning all 65,000 ports, I would be here forever. And looks like our output.txt has all of the verbose information that we could possibly want. So there you guys go. We have just built this scanner tool from scratch. It can detect your, automatically find your IP address, run in netdiscover on your local subnet. Again, assuming that your local subnet is 24 bits. And then prompt you to select an IP address returned from the netdiscover and then run an Nmap stage scan automatically for you. And yeah, this really wasn't too many lines of code. It actually fits entirely on this screen right here. So what is that, like 30 lines or something? Here, let me save this. I think I can actually figure out how many lines there are. Yeah, nano scanner. Whoops, that's not what I wanted to do. Nano scanner -L. Yeah, didn't even take 40 lines of code. Just got to be quite careful about your greps, your cuts. Just honestly take a lot of trial and error to figure out the best way to format the output of different commands. But I hope this sheds some light on the power of not only combining Python and Bash commands, but also just within Bash itself, how you can like chain commands into each other using this pipe. Really opens the way for some really powerful computation on terminal outputs from different commands. So I really encourage you guys to play around with this. Try to make some of your own improvements to the script. Like if you remember, we were having some issues trying to extract the MAC address along with the IP address. So maybe you can turn this into like a sort of all-in-one pen testing tool. Run a netdiscover on your local subnet, return IP addresses and MAC addresses, maybe prompt the user if they want to spoof their MAC address into one of the found MAC addresses. I don't know, it's something you guys can look into. I encourage you to play around with it, really make it your own, try to improve it in any ways that you can think of. And yeah, I hope you guys enjoyed the tutorial. I hope I made it clear. Please leave any feedback if you guys can think of any. If there was any way that I could have explained anything clearer or shown any process in a clearer way, I'd be happy to take your feedback and try to make better tutorials moving forward. If you've made it with me this far, I appreciate it. Thank you guys, and hope to see you next time.